Hello, everyone, and welcome back to Calculus 1. We're continuing our study of limits. As you can see, I'm working on my radio voice right now. All right, so in the previous section, I've exposed you to all the possible bad cases. I was basically trying to use fear, okay, to teach you to give you some warnings that computing limits can be tricky, but in some cases, we can avoid the problems. And the next section is all about limits of functions going to plus or minus infinity. So be careful here. We're only looking at limits going to plus or minus infinity of algebraic functions. So for simple functions, basically, instead of waiting to get a problem, we're going to manipulate the function and we're going to get the answer just by using basic limit laws or basic infinite laws to get to the answer. So what is an algebraic function? So basically an algebraic function is just you have your variables, you can do basic arithmetic, so you can add them, you can multiply them, you can divide them. So this includes, of course, all polynomials are algebraic functions. If you divide two polynomials on top of each other, you're going to get rational function. But you can also raise your function to some fractional power, like power 1/2. So if there's some square roots or cubic roots or any fractional exponent, if you have an expression with rational exponent, you're going to get an example of an algebraic function. So when you are computing limits, so big remark here, so when you're going to compute limits going to plus or minus infinity, typically what will happen is you're going to get this bad infinity over infinity or infinity over infinity. So either infinity minus infinity or infinity over infinity, but this can be avoided. Okay, so when you're going to attack, so the first thing, of course, you have a limit in front of your face. So as soon as you see that you have a limit going to plus or minus infinity of an algebraic function, this is what you do. First thing, you make sure that this expression is defined, because sometimes for a very large number or very large negative number, the function is undefined and then the answer is undefined. So make sure that this limit that you're computing makes sense. Okay, if it makes sense, then you can go to the second part. So the second part is you factor the numerator by the highest power. So typically an algebraic function has a numerator and a denominator. So you find the highest power and you factor out. So this will create a lot of fraction. It's a bit counterintuitive because you're used to find a common power and then factor out. Here it's a bit simpler to some extent. You find the highest degree term and you factor out. And you do the exact same thing at the denominator, if applicable. If there's no denominator, of course, you don't do that. And then after you factor these two terms, if there's two of them, you simplify, of course, if applicable, because if you only have a numerator or like a polynomial, you won't have anything to simplify. And then you reevaluate the limit. And the beautiful thing here is every time that you do that, if you have a limit going to plus or minus infinity, and you factor out the highest power of the numerator and the highest power of the denominator, you simplify and you reevaluate by replacing x by infinity or minus infinity. By using the basic limit laws, you will always find the answer, like no problem whatsoever. All right, let's look at some examples. All right, first example of many. So let's compute the limit of x going to infinity of x squared minus x. Of course, here you can try it right away, but I strongly suggest that when you look at this question, you see, oh, it's a limit going to infinity or minus infinity, in this case, infinity. It's a polynomial. Might as well just apply the method and get the answer through the method. But if you forget and you try it, you don't need to do that, but you're going to get infinity squared minus infinity. This will give you infinity minus infinity. So infinity minus infinity. Just a sec. My pen is acting up. So infinity, come on. So infinity minus infinity. And of course, that's bad. Oh, that kind of looks like a cute robot with 4 eyes. Anyways, so that's bad. But you don't need to do that. So here, polynomial, limit of a polynomial, highest power is x squared. So right away, this is what I strongly suggest. You just start the operation. So you factor by x squared. So you get the limit as x goes to infinity. What happens when you factor by x squared? Well, this is the same as dividing by x squared everywhere. You don't need to write the division if you're comfortable with the factorization and you simplify in your head. I'm going to do it just for a couple of examples just to show you where how the simplification works, but normally at some point you can just simplify right away. So you just divide every term. My God, I have a hard time again with my... Okay, so x over x squared. So you just divide by x squared, you simplify, so you get the limit as x goes to infinity. X squared over x squared, that's just 1. X over x squared, that's 1 over x. And now by evaluation, so if you replace x by infinity, you're going to get infinity squared, 1 minus 1 over infinity. And of course, what happens here is that for every single fraction that you're going to get, you're always going to get 1 or a number over plus or minus infinity. All these fractions will go to 0. Infinity squared is just going to be infinity times 1 minus 0. So you're going to get infinity times 1 minus 0, which is just infinity. And you get your answer that way. All right, next example. So we have the limit going to infinity of 3x cubed minus x squared plus 1 over x cubed minus x plus 2. So if you plug infinity here, you're going to get into trouble. Normally, I just see it. I have a limit going to plus infinity of a rational function. So here we go. I just identify my highest powers and I start my simplification. So normally when I do this, so I get the limit as x goes to infinity. So at the numerator, the highest power is x cubed. So if you divide by x cubed and simplify, so I'm going to do it in one step now. So x cubed over x cubed, that's just 1. So you're leaving behind 3. X squared over x cubed, that will simplify to 1 over x. And 1 over x cubed will just become 1 over x cubed. And then it turns out that for this question, at the denominator, we also have x cubed as a highest power. So we're going to also factor by x cubed. It's not necessarily the same, but in this example it is. So if you factor x cubed out of x cubed, you're going to get 1. X cubed out of x, you're going to get 1 over x squared. And 2 out of x cubed out of 2, sorry, you're going to get 2 over x cubed. And now you simplify. So here you can see this x cubed will cancel perfectly, this x cubed here. So now we can start the evaluation process. So you get 3 minus 1 over infinity minus 1 over infinity cube, all that over 1 minus 1 over infinity squared plus 2 over, infinity cube. And here you can cut the crap. Okay, oops, sorry. Any fraction with infinity under, okay, will all those fraction will all go to 0. You don't need to square and then do division. Okay, you know where this is going. So this is 3 over 1, and this is just 3 at the end. Okay, so here, of course, you can talk about what does it mean for that function. It means this function has an horizontal asymptote on the rightmost side at y equal 3. But that's not the point of this question, but it will be, okay, at some point. All right, let's just do another example. So more. So here we go. So next example. Oh, wait. All right, so highest power at the numerator is x5. The highest power at the denominator is x cubed. So that's factor. So you get the limit as x goes to minus infinity. So minus infinity. The highest power at the numerator is x5. So you're going to leave behind 1 minus 1 over x5. At the denominator, you're going to get x cubed out. You're leaving behind 100 plus 10 over x plus 10 over x squared plus 1 over x cubed. Now you simplify. So if you do simplify, so the x cubed will cancel completely with this x5, leaving behind just a new power, which is 2. So now you evaluate. And notice here, I haven't mentioned this a lot here. A lot of people, they worry about the proper solution notation. And the idea here, and typically they are wondering about when is the limit term going away. The trick to remember is as long as your variable x is inside your equation, the limit term should be up front. As soon as you replace x by something, a number like a, or a number to the left like a minus, or a number to the right like a plus, or one of the infinites like plus infinity or minus infinity, then the limit notation is gone. So if you replace x by minus infinity, so here we have minus infinity squared, 1 over minus infinity to the power 5, all that over 100 plus 10 over minus infinity, plus 10 over minus infinity squared, plus 1 over minus infinity to the power 3. And again here, I know this is where these fractions are going. So every single fraction where you have a power of plus or minus infinity at the bottom, all these fractions, okay, they're going to go to 0. Oh, now I'm drawing nice arrows, huh? You like those? So all those fractions, okay, they're going to zeros. You're left with what? You're left with minus infinity squared times 1, which will be infinity over 100. Well, infinity over 100. Okay, that's just infinity again. Okay, so there's no vertical asymptote on the leftmost side of this function. It goes up forever. All right, more examples again here. Another limit going to minus infinity of a rational function. So here we go. So let's find out the highest power. We have x squared here as the highest power of the numerator, and it's x cubed for the denominator. So here we go. We start our factorization right away. So you get the limit as x goes to infinity. Sorry, I mean minus infinity. So the limit as x goes to minus infinity. Now I'm factoring by x squared for the numerator. So x squared, leaving behind 10 plus 17 over x squared. All that divided by factoring by x cubed, leaving behind 1 plus 1 over x cubed. Now let's simplify a little bit. So here the x squared will completely simplify with the x cubed down there, where the power 3 will just become power 1. You don't need to write the power 1, but I'm just going to put it there. And now, because I'm about to replace x by minus infinity, the limit is gone. So you just have 10 plus 17 over minus infinity squared, all that over 1 plus 1 over minus infinity to the power 3. And again here, every fraction, you don't even need to do all the steps on the test. So all the fractions, even if you go through the steps, they will always lead you, okay, to a bunch of zeros. So all these terms here, okay, so all these, a low arrow, I need you, red arrow. Come on. Okay. Come on, oh my God. Okay, this one is going to be an ugly one. No, here we go. Okay, so all these terms are going to go to 0. Okay, so you're just left with, oh, I forgot my infinity down there. Sorry about that. So at the front here of the denominator, I forgot to write my, come on. So minus infinity down here, forgot that minus infinity. All right, so now what are you left with? You're left with 10 over minus infinity, and any number over any power of plus or minus infinity is just going to give you a nice 0. So this function has a horizontal asymptote at y equals 0 going to minus infinity. All right. Next example. So here, so far, all the examples we've done were either polynomials or rational function. But when you have square roots, you have to be careful because your expression could be undefined. So for example, here We have the square root, so the inside here could be negative as you choose a very large x, positive or negative. So here, before we do anything, just by inspection, we ask ourselves, is this expression defined? Because of the square root, what happens? Well, in this case, I have minus infinity, but because it's going to be squared, and then because it's going to be squared, then you're going to get plus infinity plus 1. So everything is going to be positive. So this one, okay, will not crash. So you can apply the method here. So here we go. So now what do we do? So the highest power at the numerator, change color here. Let's go green. So the highest power at the numerator is x squared, and the highest power at the denominator is x. So let's factor by x squared, but be careful, you're inside the square root first. So there's a little bit of algebra here that you're going to be, that you need to be aware of. This example is probably the trickiest, okay, of this section. So you are factoring by x squared, leaving behind 1 over x squared plus 1, and you're under a square root. And down there, you're factoring by x, leaving behind 1 over x minus 1. And now you have to take out, okay, this square root out of the bracket. But be careful, the square root of x squared, a lot of people think it's x, but it's x if x is positive. Just a friendly reminder here on the side. I'm going to do this in red. Okay, for example, if you have minus 5 and you square it, and you take the square root, what do you get? You get the square root of 25, which is 5. So it's not just, okay, so in there here, it's not just x. So here, because my x is negative, because we're talking about a limit going to minus infinity, when you're taking the x outside, you need to do the absolute value of x. So here, like I said, this is a tricky one. So be careful, because x is negative, you need to take the absolute value, because the square root of minus 5 squared is plus 5. Okay, so make sure you see that. So here you get the limit as x goes to minus infinity of the absolute value of x, square root of 1 over x squared plus 1. All that over x times 1 over x minus 1. Now you want to do some cancellation, but how do you get rid of an absolute value of x? So you cannot simply cross the x's here. Okay, you need to get rid of the absolute value, but one way to compute the absolute value algebraically, so if you have something negative inside and you multiply by minus 1, then you're going to get the same thing as doing the absolute value. So what I mean by this, again here, I'll do this remark on the side. So if you want to compute the absolute value of minus 5, what you can do is multiply minus 5 by minus 1, and it will make it into something positive. So you can get rid of the absolute value when the absolute value is negative, when the x is negative, by multiplying the inside by minus 1. So here the absolute value turns into minus 1 times x. So be careful what people say, oh, now it's negative. Remember, the x is negative. Okay, so it's going to make it positive with this minus 1 up front. So it's good. It's a good thing. Okay, so let me just do the square root properly. So you get 1 over x squared plus 1. And down there you have x times 1, open bracket, 1 over x minus 1. And now you can simplify. Now this x here simplifies that one. And now we're ready for the evaluation. So here, when you evaluate, the limit goes away. So you get the square root of 1 over minus infinity squared plus 1. All that over 1 over x, over minus infinity. X is replaced by minus infinity everywhere. Minus 1. Again here, remember, okay, all those fractions, they're going to go to, they're going to go to 0. So same thing for that one. Come on, my arrow. Come on, here we go. So that fraction also is going to go to 0. And now, what you're going to get the square root of 0 plus 1, which is 1 times minus 1. So if you write everything here, you get minus 1 times the square root of 0 plus 1 over 0 minus 1. And then if you do the math here, you're just going to get -1 at the end. Okay, so a +1. Sorry, yup. So be careful. Okay, so +1. Okay. This is probably the trickiest question in this section. Okay, so the taking out the absolute value out of the square root is something that people kind of forget sometimes. All right, next example, again with rational expression. So the next one, this is where if you don't think about it, you could go and I've worked too much on it. So here for the next one, so we want to compute the limit of the square root of x over the square root of x plus x square root of x. And you're computing the limit for x going to -infinity. But hello, if x is replaced by a big number that is negative, this expression is not even defined. So here's the answer, undefined, and that's it. Okay, so there's nothing to do. You don't need to factor. If your expression is not defined for very large positive number or very large numbers, then you're done. Okay, so this question is done. Of course, my next example is a clone of the previous example, where now we're going to go to +infinity, and because we're going to +infinity, if you look at your expression at +infinity, so my x here is positive. So everything will be defined. So sadly, okay, you have to do the whole thing here. So you have no choice for that example to go through the steps. Okay, so before I go through the steps here, I like to identify which one is my highest power. So here, my highest power, and I'm just going to rewrite them first using power notation. So this limit is the same as the limit as x goes to infinity. Root of x is x to the 1/2 over x to the 1/2. And here we have x to the 1 times x to the 1/2. These powers will add up to x to the power 3/2. And now I can see my highest power. So of course, at the numerator, I have x to the power 1/2. And at the denominator, my highest power is x to the power 3/2. So of course, there's nothing to factor at the numerator. It's only one term. So I just need to factor by x to the power 3/2 at the numerator. So here we get the limit as x goes to infinity of x to the power. So the numerator does not change, x to the 1/2. So down there we have x to the 3/2. So if you factor x to the 3/2 out of x to the power 1/2, you're going to get x to the power 1/2 minus 3/2, which is x to the -1, or 1 over x plus 1. And now, of course, these things simplify perfectly. So the x to the 1/2 will cancel the x to the 3/2, and the new power will simply be 1. Okay, so, and now that we know the power, let's just change the color just to see the simplification here. Now, if you replace x by infinity, okay, you're going to get 1 over infinity times 1 over infinity plus 1. That fraction here is going to go, of course, to 0. So you're left with 1 over, change my color. No, sorry. So you're going to get 1 over infinity times 0 plus 1, which is 1 over infinity, which is 0, skipping some steps here. Okay, so you're just going to get 0. So be careful if you simplify too soon. Okay, just as a remark here, if like the previous question, if you simplify too soon and you plug your -infinity, it will give you 0, but it's going to be wrong. Okay, so always make sure that your expression is defined before doing any manipulation, because sometimes if you manipulate and you simplify your expression, you will get something incorrect. So always check. So for polynomials or rational function, you don't have to worry about it. It's only when you see square roots or even roots in general that you need to wonder, if I put a very large positive number or a very large negative number, does this expression crash? If so, you're done with the question. It's just undefined. All right. For this section, that's it. That's all. Bye-bye.